Okay, here we go. Guys, so here's the aim for today. This is not necessarily something that you haven't done. It's just a kind of question that when you will see on your take-home test that I would like for you to recognize and be able to do better. There's no easy way to do this because there are lots of right answers. So there's no one way to do it. It's about pattern recognition. Use summation symbols to write each sum in sigma notation. The other reason I'm asking you to do these problems is because I have no life. I sat and combed through the Regents exams, and they keep asking this question. And it appeared twice in a short answer, so I feel like you should know how to do it. So let's do the first one, summation note, sigma notation. Sigma notation uses this lightning-looking S symbol that everybody claims they have a problem drawing. Yeah. That's sigma. And so basically you have to use this kind of notation to rewrite 1 plus 2 plus 3 plus 4 plus 5 in a simpler, more condensed form. Ooh, I like this. Well, let's just use x. So x equals 1, and what is it x going to go up to? X is going to go up to 5, and then we always stick a formula over to the right. What's the formula that when you plugged in x would build this thing out? I think it's just x. Okay. What do I mean? There are lots of answers, and yes, you guys are definitely calling out some right answers. Look, this formula, if you're given, says start at 1 and plug in until you get to 5. You could do x minus 1. You could do x plus 1. If you choose to change the formula on the right, it will change your starting and ending points. But does everybody get this easy example for this one? Okay, and then in the next example, we're going to talk about different ways that you could write the right answer. So everybody's got this down. What? This is easy? This is all you have to do. That stuff in green is what I want you to write down on your take-home test, or something like it, you know. Okay, so take a minute, write all these numbers down now, and then we're going to talk about it. Don't yell out. Give everybody a chance to try and figure it out. All right. So we got some people to write this down, and I didn't record this, but yeah, we got some crazy people. We got some people throwing up some crazy formulas. No, the pattern is just they're perfect squares, but there's different ways that you could write this out. Now, some people in first period said, "Oh, I'm going to write it out this way," and then people in second period said, "You know what? I didn't even think of that. I thought of writing it out like this. Is this wrong?" No, it's not wrong. It's just what do you have to start at for this to be true? And then what does it go up to? Oh, because 10, like that's the last number that you'd have to plug into this right one. 10 squared is 100. But over here, we get the added bonus of plus 1, so we only have to, 9 plus 1 is 10. Yeah, okay. So that's what we do. Wait, that's how we do? That's how we do. Okay. All right. We're almost done. We only have one more problem to go. So this one, maybe I got out of hand. I got out of hands, and this one's really hard. But as Courtney was teaching me, she said, you know what? I think I see a pattern here. Well, this is something that we've been doing all along, right? It turns out to get to each successive term, you got to multiply by a fourth. Each time. So just out of curiosity for your, let's go over some vocab. If you're multiplying by a constant ratio, what kind of sequence or series is it? Is it arithmetic or is it geometric? Geometric. And you've seen examples of geometric sequences before. Where does the common ratio go? It always goes in parentheses. Yeah. There you go. That's part of the anytime you see this written in a summation equation, it's almost most definitely a geometric sequence. Three. There are three kinds of sequences. There's arithmetic, there's geometric, and then there's the neither. Like you're totally random, dude. I don't even know how we found a formula to find you. Now are we done? Of course not. It's because how do we get that first 64? That has to factor in here somehow. Do we put a 64 on the left? And we're not putting it on the bottom. On top? The number on top is the things that we're plugging in for x. We put it in the front. Because, Henry, here's where it doesn't make any sense. I'll explain to you why. Right? How do we get this first term if there's a 64? What does it have to start at to cancel this out?
0.
Yeah, it's got to start at the 0 power because anything to the 0 power is 1. And so if it starts at 0, then it becomes 64 times 1/4 to the 0. And that's 64 times 1, which is 64. And then by writing it out, we're able to recognize that I need 6 1/4. I think. 1, 2, 3, 4, 5, 6. So we're not sure, we got sidetracked. We're not sure if we recorded the end of the problem. But at the end of the day, here's what goes down. It turned out to be a geometric sequence. The common ratio was 1/4. In order to get this first number over here, you needed this stuff to eventually, this stuff right here, to eventually become 1. And the only time you get 1 is by raising it to the 0 power, which is why we're going to start x at 0. Therefore, the first term just is 64. And from there on out, you get 64th times 1/4 to the first. That'll produce 16. 64th times 1/4 to the second. That'll produce 4. All the way down to 1/64. Last problema. So Felice, what are you thinking? You think it's +1? What do you want to do? What's the formula you want to use? That's okay. That's okay. That's the easiest version of it. Now, there are some other people that came along that said, no. Whoa. I did this. Jason, what'd you do? You did x minus 1. If you do x minus 1, what do you have to start at? And what do you have to go to? That'll work. It's not dumb. That's what I mean by it's this. That's why this is hard to teach. Is that there's so many different ways to do it. It's going to take forever for me to grade it. Yeah, you could do like literally so many different ways. It's going to take forever for me to grade it, which is why I hope I asked an easy question so that like most people will come up with the same answer. No, don't, please don't. If you can, try and make it easy, but I understand if you like to do some crazy stuff. And that's all I have for you for today.